It's a fantastic thing. So, thank you so much, Johannes, Thomas, and Thomas, also professors that came with us. Dr. Anne Bain is a full professor in architecture at the Royal Danish Academy School of Architecture. As head of the Center for Industrialized Architecture, CIMARC, she leads research into ecological solutions for the building industry to improve architectural practices according to the planetary theories. This includes applied building material studies, building structures, theories, practices, and tectonics. Since 2014, she is the chair of the graduate program SET, Thermal Ecology and Tectonics. In 2023, she was awarded the Jan Schumann Prize for Architectural Writing Boutique. Invited by Pedro Bravo, the sign exhibits prefabricated by the German facade, part of the Certificate at the Mass Architecture of 2025. Selected books, Materials, Architecture and Technologies, 2023, 2023, Construction Materials, Architecture and Tectonics, also 2023, Circular Construction Materials, Architecture and Tectonics, 2019, Tectonics, 2015, Televisions in Architecture, 2004. Well, to give the floor to
Thank you so much. Thank you for the introductions. Both of them understood a little bit of the Spanish, and thank you so much for this opportunity which came after the visit in the desert, Atacama Desert, where we also had a small lecture. Both myself, Johannes, and Thomas, we were all speaking about our work. And for this lecture, I'll do it a little bit different. I'll also speak about biogenic architecture, of course, but I'll also tell a little bit about our academy. So you have an idea of, what the greater context of what we're doing, the school we're part of. So I got the title. Arquitectura Biogenica. I guess it's biogenic architecture. And I will talk about research in biogenic architecture. As for the structure of the lecture, I tried to divide it into 3 parts. A short introduction to the Royal Danish Academy, the School of Architecture, short introduction to CINARC, the center in which we have worked with industrialized architecture for many years now, 21 years, I think, 21 years. And then, of course, the present research into biogenic construction. But first of all, we are a very old school, situated in the center of Copenhagen. It was the first architectural school in Denmark, founded in 1754 by the King Frederick V. And the Beaux-Arts, École de Beaux-Arts in Paris, who's the oldest school, but I think we're just about the same. In 1996, we moved out from the Royal Castle Charlottenborg, which is situated in the center of the city, to the former Navy Yard Holmen. And we got into these new fabulous environment, new old buildings, but new settings. And it's right on the harbor front. In 2011, we had a merger together with the School of Design and the School of Conservation. So today we are called the Royal Danish Academy School of Architecture, Design and Conservation. The School of Conservation is very small, but the School of Design and Architecture is just about the same. Design a little bit less than architecture. And in 2014, we had a new academic structure at our school. Actually, we just had another one this year, or 25. Not as how do you say, serious as the one we had in 2012. 14, we aligned the education, the architectural education with the Bologna Treaty, the EU regulations, that we now have a bachelor's degree of 3 years and a master's program of 2 years. So it's 5 years in total to become an architect according to the ACE, the European Architectural body or association, to call yourself an academic architect in Europe. So today we have about, I think these numbers are not all adjusted, but I think in architecture we have about 800 students, and in total we are about, I think, 1,400 together with the design school, and conservation is growing a little bit. We are, as you see here, the red dot. That's where we are in the center of Copenhagen, in the old part of the city. This is an artificial island that was created by our King Christian IV, and he was also the client or the building master of the Boers that burned. I don't know if you heard about it, but it was a very fine old building that burned last year to the ground, or half of it burned to the ground. But he also formed these islands, being part of the naval yard. And we are now situated in these buildings. It's a you could say, natural heritage area. The buildings are listed and protected, and in the area around it, we find new developments of housing. And the red buildings you see on the very top are actually rowing boats for the small cannon. It's called the cannon sheds, and they're highly protected. And now they are housing different architectural firms and design firms. But we are now in the architectural school. We are now see here, this part, we have the design school in this part here. So the Royal Danish Academy, we used to be called the Royal Danish Academy of Fine Arts School of Architecture, because we were part of the fine arts school, in which, as I mentioned before, we had both painting and sculpture and architecture. Those were the three topics. And now we're just the Royal Danish Academy School of Architecture. We have 4 institutes or departments: architecture, urbanism and landscape, architecture and culture and history, architecture and technology, and architecture and design. You kind of think, well, isn't it all about architecture? But it's very important that every time each institute or department disseminate, everyone knows that it's not just technology, it's architecture and technology in this case. So this is our institute. We have a bachelor's programs called Anatomy and Fabrication, and we have 3 master's programs: Architecture and Technology, which is not an architectural education, but a more sort of, it's called a constructive architect education. We have our program, Settlements, Ecology and Tectonics, and we have computation. Then we have 2 research centers, CINARC, Center for Industrialized Architecture, and Center for IT and Architecture. As for our institute, we have like a broader perspective looking into technology, but from an architectural approach. So we look into, and this is also particularly, you could say, interesting from the CINARC perspective, the process and product, building practices, manufacturing product and processes, the tectonics and structures that are structural engineering, building technology and materials. And then we used to have climate and comfort, and that has, we are now sharing that with the Institute of Design. We used to have daylight, acoustics and indoor climate, and now we only have the building physics, indoor climate capacity in our institute. And who's CINARC? We are a fairly small group of very committed people. We have a number of full professors or associate professors, and we also have an industrial postdoc and two PhD. One of them is also an industrial PhD with Henning Larsen Architects. And Torbjørn in the upper left or right is also with a large entrepreneur who's looking into design for disassembly. This map, I change it once a year or every half year, more or less, because we have projects coming up, projects that are finishing and projects that keep going on. And I'm not going to go into great details, but just to show you that the green bubbles, those are the ones that are current projects and they are externally funded. I think that's something which is fairly new within the Danish research setting. We are usually state funded. We have, I mean, our full appointment with the university is fully funded by the university or by the academy. But with many of the projects, we have to apply for private funding or additional public funding to make them happen. Also, the project we have right now, which you see in the upper center, Biogenic Construction MUDP2, in which Thomas and other good people are involved, is also partly publicly funded, but also funded by the companies who are taking part. And then we have like the two pinkish, reddish bubbles. Those are applications that are being worked on. The Horizon EU Down to Earth project is a fairly large project together with a group of Spanish, Belgian, and German, Dutch, I think even also Swedish participants across EU, in which we actually look into similar topics as for biogenic construction. We look into the construction material pyramid and how we can apply materials that are regionally situated and how we can develop building construction from an architectural perspective that is taking care of the local resources and the local environment. But SINA, just to make it short, we do material research, applied building technology, ecology and sustainability, and tectonic ecology, as we call it. So these are sort of the different topics that are connected. As for the center, I mentioned it's about 21 years old, and we've been a number of different people over the years, and some like Nini, who was on the image or the slide just before. She was one of the first industrial PhDs, and together with a masonry manufacturer. But from that perspective, we were invented by our former professor, my late professor, and two other professors who were asked by the Ministry of Culture. At that time, our school was run by the Ministry of Culture. And in 2011, I think, we were moved to the Ministry of Education and Research, which was quite a great change coming from, I mean, a purely cultural setting, formal setting, into a more sort of determined or directed research and educational ministry. But we were invented at that time because our late professors were thinking that we had to reach and bridge into the industry and become, I mean, how do you say, get out of the bubble, the academic bubble, to engage with external partners from all different kinds of organizations and entrepreneurships. But from the very beginning, at least from a personal interest, we have been looking into the ecology, understood in a sort of a larger setting, not just about the biology of ecology, but rather than how things are interconnected and interdependent. The question about frugality, how to use less materials and work in more simple ways, and also about buildability. How do we transform the construction industry and make things buildable, so we don't just make visions, but also sort of try to transfer these visions into real-time construction. But this is part of our departure, that architectural research is our interest that pushes the building industry towards absolute sustainable solutions, that supports the development of clear strategies for Danish architects to get a strong international position in developing an ecologically responsible architecture, that strengthens the tectonic understanding in education and in the profession of architects. I'll get back to the whole sort of definition of tectonics in a second. So the task of the center was to, or has been ongoingly, to develop, accumulate, and coordinate research and education activities that focus on industrialized architecture from a sustainable perspective, to outline and revise specific concepts, characteristics, methodologies, processes, and products that define the field of sustainable industrialized architecture, and to clarify embedded and present problems and potentials in the building industry and architectural practice. And finally, to collaborate with the building industry and relevant partners. So our architectural focus, it's very important to say that we are all trained as architects, but we work across engineering and other sciences, collaborate with other sciences. But we have a very strong architectural focus. And again, we have these sort of three main points. We want to improve building designs and construction by use of sustainable materials and combining craft and advanced industrialized manufacturing. And we want to look into the sustainable potentials environmentally, controlled industrialized construction, new supply chains, and systemic thinking, including both quantitative and qualitative approaches. And finally, we want to change the role of the architect in new building processes, business organizations, and collaborative setups. We want the architects to be empowered to take part and not just think within their own sort of regime, but engage with other fields of knowledge and practices. But as for the tectonic, and I could have a whole lecture or a series of lectures about tectonics, but I'll spare you for that. We have, as I mentioned here, the tectonic alphabet. It's one of our fine colleagues who sort of invented this. But the whole idea of tectonics is actually reaching thousands of years back in architectural history. Tectonic means in ancient Greek, it means the carpenter or skilled with an axe. So it's sort of the crafts person who is cutting down the trees and making the construction into building. And as you probably have thought about, architectonic means the superior carpenter, or the superior master builder. And that is how these things are linked. So it's not just about, actually, it's not about geology. The geologists took our concept and made it into a geological concept, but actually it's a very deeply architecturally embedded concept. And this we have been studying in different ways in research projects and PhD projects, but also in real-time practice. So what we define as tectonic is that it's the correlation between the architectural intentions, the material properties, the form principles or the anatomy of the structure or the building, the choice of building technologies and structural rules that is presented in construction, or the principles. So it's about the specification, designing, the joining of materials and elements to form an architectural synthesis. And also tectonics holds an architectural ethics and an effective way to direct and control resources in construction. So from that perspective, we also find that tectonics is actually a very, I'd say, active concept to apply. And what you see here, the small diagrams or the pictograms, is invented by Søren Nielsen, who was actually a former colleague of Thomas sitting up here, having many years in practice, and now he's a professor at the School of Architecture in Aarhus. And he sort of made this alphabet in order to help himself when he was doing part of his PhD project. So in CNARC, we have like 3 levels of research. We have what we could call strategic research, that is more so theoretically based and basic. We have industrial research that is more implied and innovative, and experimental research where we have investigations into materials and construction. So I just have some few examples of the different strategies. In this case, strategic research or theoretical research, we have, in this case, a long-term project that has been going on almost the whole lifetime of CNARC, where we look into IPDs, integrated product deliveries, which has become part of regular construction practice in Denmark or in most of Europe. So it's about how industrialization meets sustainable architecture. It's sort of like a dichotomy, these two dimensions of in industrialization that is more, you would say, technocratic and limited, and it's about repetition and uniforming or unifying the different elements. Sustainable architecture or architecture per se is much more diverse and more depending on different context and settings. So this meeting between these two worlds has been sort of the fundamental question in these projects. So over the years, we've had now it says 4 seminars, 7 publications, 3 PhD dissertations, and a number of different collaborations. So when we look back or look into the results, we've had a fundamental, a very important PhD project that was looking into the system structures in architecture. I think the working title was Design Systems, Systems Designs, or Design Systems, Systems for Design. Actually, again, from this tectonic perspective, how to sort of look into the different principles and how to organize and categorize the different sorts of approaches. This also came out as a book published with Routledge after the dissertation was defended, and the PhD student later became a specialist in industry, working with a high-end company, also working together with Arab, the Arab office. And finally, we had one of the recent projects, new PhD projects that also looked into, as you may see with the little drawings down there, the tectonic alphabet and also the construction material pyramid, who is now an associate professor in our institute. So as for the industrial research, we have one of the early projects or collaboration was with the masonry industry. This led to 2 industrial PhDs over the years, also a number of different activities, conferences. We had a think tank together with the industry, and also international conferences and seminars. And the specific sort of the main body of work within that was this masonry block dissertation, which is now our dear colleague, Nini Leiman, who was testing not only the theories, but also practicing ways of implementing these new masonry blocks into Danish building practice. At this time, we had not applied these masonry blocks beforehand. It was like a completely new material. It has been applied in Germany, most of Southern Europe, but not in Denmark. And now slowly, after 20 years, it's slowly being implemented. It takes a long time. So even though you have the innovation, you have the bright idea, it may take a long time before it's fully implemented into the industry. So as for the industrial PhD projects, and I could mention even more, we've had a very deep material interest or different topics. We have been bricks and masonry, concrete and formwork, wood and tectonics, and now over the past 10 years, we've also looked very much into circular construction, circular economy. And maybe I should just mention that these PhDs have been funded by industry, partly by industry and partly by the Innovation Foundation, which is a public grant you can apply for. And as for the experimental research, as I mentioned, Søren Nielsen, who was also an industrial PhD, unfortunately, he didn't finish his degree, but he did some very, very brilliant work and also developed these tectonic principles, as I mentioned, which he sort of compared with technical principles. So he was like, when he was developing in this case, circular construction elements with reused materials, he was applying the sets of tectonic principles as a way to sort of align and specify and clarify what is actually at stake, what is important. Is this a matter of profiling? Is this a matter of consoling or clamming, whatever. And then because usually we only deal with construction as from the technical perspective. So we wanted to bring the tectonic architectural way of thinking into the technical specifications, which I find as a brilliant way of approaching this question. Also in CNOC, we designed and constructed this small pavilion in CLT. At this time, not much had been built with CLT, and it was a self-sufficient pavilion or small unit, in which one person could, maybe not as in the Deserta Ecofoli, I mean, there was no water supply, but there was electricity and there was a ventilation shaft, as you see maybe in the far corner, which had been developed by an engineer at DTU, the Danish Technical University. We wanted to test it in this construction, and it seemed to work very well. And now it was sitting at our school being monitored for 1 year, and then it was moved to a free town right next to our school, Christiania, where it's still sitting. So when I'm writing question mark, it's because it's still sort of an experiment to see for how long it can stand or sit outside without cladding. It's just the CLT elements being exposed to the weather, which is very critical, but we are sort of interested to see for how long it can last. And finally, we have also before or parallel to the biogenic projects we're doing at the moment, we have also several projects looking into what we call circular tectonics, design for disassembly, and ways of improving building practices, both as for using reused materials, recycled materials, but also using materials that have a very low CO2 emission, and that can be reapplied and reused or go back to nature in different ways without harming nature. So this project we were doing from 2017 to 19, where we did 3 different structures, one in straw and one in unburned clay bricks and reused clay bricks, and then wooden panels. What was very important in that project was it was all made for design for disassembly, that each fragment of material or fraction could be separated into the different sorts of materials, so they could either be reapplied or be discarded and have some new sort of metabolism. And now I'll just briefly explain a little bit about the project, which led to also the collaboration we have now with Petra and Pamela and the UC University. This was a project that came out, you could say, on the back of the former circular construction project, but also due to the fact that the Thatchers Guild approached us in 2017, I believe, and asked for collaboration on projects on how to use thatch for new architectural purposes. And this was the group of people involved. We were very much aware of the fact that one of the showstoppers for using biogenic materials, and in particular, is the concern about the fire hazards, that it easily, or at least there's an idea that it easily burns, but there can be, we wanted to work with different technologies and methods in order to show that we could handle the fire in different ways. So this is the group of people, just to show how many people are involved in a project like this. People here from the industry, from the Danish Fire Security Institute, and from CNARC at that time. As part of the construction material pyramid that was developed, as I mentioned earlier, in a PhD project, we have tried to use this as a methodology, or as an approach to look into materials that have a very low CO2 emission. And among those materials are reed, which is also used for thatching in Denmark. And we wanted to go much deeper into this about the renewable materials or regenerative materials, the local plants or resources, and also that it has multiple properties. It grows, as you may see, in most parts of Denmark. It's a perennial plant that grows every year. You can harvest it, and it grows every year. And also it has many good environmental properties as for the natural environment, both in terms of biodiversity, as for nitrate extraction, and also as CO2 or carbon storage. So this project, we both wanted to go back in history to look into Danish building traditions, to see if there had been ways of building and using materials in different ways that were concerned about how to apply clay as a fire retardant. And we found this little building, a water mill at the Open Air Museum right outside Denmark. But we also saw, because we wanted in this project to test reed applied for facades, not only for roofs, but also for facades. And we found these small houses, or few houses in the southern part of Denmark, that has the reed as a sacrificing layer on top of clay walls. So we did a series of fire tests and tested different sorts of mineral aggregates that could be applied to the biogenic material, to the reed. And we found that three items in particular were working very well. It's put into this little oven, as you see here to your left, and it sits there for about 20 minutes. It's a single burning item, meaning that it's only testing how the reed, together with in this case clay, how it reacts to the fire. So after that, it's being sort of documented for how long and how it burns and how much is left. Then it was made into full-scale structure or panels that could be tested likewise. And this was only the three who performed, or actually the two who performed the best. The one you see here to the left in the other image, that's actually the baseline that's untreated. And the conclusion from this first project was that clay does have is highly efficient fire protection for vertical thatch facades, and it can be compared to the fire class 2. But also that this particular structural composition was also made for this particular fire test. So our next step in the project we're doing right now, we want to build up construction or structures in ways that actually we hope, I don't know if we can make it, but I hope we can get closer to the fact that people in the construction industry can replicate this structure, because this was particularly made for testing. But what was very interesting was that they put, as you may see on the very right, there's a clay plate is inserted into the thatch to sort of make sections, but also to prevent the fire to spread across vertically across the surface, which also had a fire protecting property. Then we also in this project tested the CO2 emissions. I mean, we put the materials we applied into the construction material pyramid and compared it to a regular one-family house construction, a wall construction. And this is upfront carbon, meaning that it's not the materials, how the full life cycle of material as for the life cycle of the whole building for its full lifetime, that may be 100 years or more. But this is just looking at the numbers when we harvest the material, have them transported to the building or the construction site, and the CO2 emissions that are part of this full calculation. So as you see, the regular construction, this is lightweight concrete, mineral steel and cement, has a high impact, whereas the biogenic materials has a very minus impact. And now I'll speak about a different approach within the field of projects we have been doing. This was parallel, I believe, to, or it came right after this first project. There was a call amongst, or the Danish foundation, Dreyer Foundation, had this call about reset materials. They wanted the architectural profession across practicing architects, universities or researchers to engage with artists and work within different material regimes. So in this case, we were offering the proposal of looking into what we call explorations into the biogenic architecture for the future. That is looking closer at the tectonic culture of reed. And in this project, we worked together in SINAG, now Lykke Arnfred, who is a PhD student, and Line, who has just graduated as a PhD student, but moved to a different institute, the Institute of Design, again, the DBI, Institute of Fire and Security, but also the artist Tove Stork, and finally Thomas, and also Barbara Feline Ebbesen of Thatcher, who have been helping us out both with the materials and building it. So as mentioned, the framework was this open core reset materials, and it was quite interesting and also very challenging from the perspective that the foundation kept changing the how do you say the framework for the work. So we had to begin with, we were just giving the grant to sort of develop whatever we wanted, but after a few weeks, I believe they sort of set up a number of different, how do you say, questions or challenges we had to reply to. And in this case, we were to finish up in an exhibition. We knew that from the very beginning. And we also had to work together with an artist, as I mentioned. We called the working title for the project, we called Burned and Bundled, because we looked into the two sort of main, could say, problems or challenges we think about when we think about reed or grass, is that it easily burns, but it has no structural property. So these were sort of like the main challenges we wanted to look closer at. So we wanted to look, as I said, unfolding the will of the material. As for the background of the project, as I mentioned, we had the biogenic construction, what we call version 1. That was also the fire project I just showed you. That was exhibited in a full-scale construction at the Royal Danish Academy for the exhibition 70% less CO2 for the built environment. And in this case, we built the in situ construction of reed and inserted clay plates and impregnated with clay. And it was a full structure of a load-bearing straw panel with the reed on top and clay plaster on the inside. Then we were replying to the call for the Triennale Arquitectura exhibition in Lisbon in 2022. And for that, we then developed the second version of the biogenic construction, in this case with prefabricated panels also produced by Thomas, as you see in the image here. This is one of the first demonstrators or test prototypes. And the panels on the far right, that was sent to Lisbon, built for the exhibition, and where Pamela and Pedro were also curators of this part of the exhibition. I remember it was called Terra, the full exhibition, and this part was called Cycles. So it's also about recycling and design for disassembly. The second or the third generation project was also looking into prefabricated panels, in this case combined with the brick block, also which we have looked into in the circular construction project earlier. But in this case, it was together with the architectural company Renault Ledengori, who has been working with these blocks for many years, trying also to implement them into Danish construction industry. And this project had to be built, or how to say, conceived in such a way that it was to be tested or built for full-scale construction in 5 stories. And we had to prove, we had to sort of document, I'm not going to go deep into that, but we had to document how would this construction comply with the CO2 reduction of 75%, right? 75% reduction from regular construction. And as you see here, the panels again are now in a different version, because when they're all put up, you can hardly see these are prefabricated panels. It looks like an in situ construction. but it's actually prefabricated, the whole structure. So what has been very, it's like an ongoing field of study is the tectonic principles, which we have been looking into. It's about the material properties themselves. It's about the prefabrication, and it's about the construction details and joints, how they are being developed and how they are being formed differently, depending on the different structural principles or the exact setting. So as you see here to the left, this is actually the joint of the Triennale pavilion. Those are the elements you see right in the center, and to the far right, that's from the pavilion, the UIA pavilion. So in this project, as I mentioned, we had the problem statement about exploring the will of the material, or the nature of the material. And we knew that it has a number of potentials. As mentioned, it's available. It's a local material in a Danish setting. It's a rapidly growing resource. It embeds or holds CO2 in the structure. It's renewable. It's already a part of the existing building culture and techniques. It's recognized. It has a very special tactile aesthetics. It has a plastic character. It can be formed or worked with in many different ways. And yeah, as for the challenges, we knew that we had the fire hazards, or the fear of fire hazards. And as I mentioned, it's not considered to have any structural capacity, and we don't find any industrialized solution as for construction. So these were like the three main questions we wanted to address in this project. But it's also part of a larger, how to say, theoretical questioning or positioning. And having or being part of the architectural theories connected to tectonics, also being very much inspired by Kenneth Frampton. He speaks about architectural persistence, in which he defines it as it can mediate forms of modern civilization and local cultures in ways that support identity-giving cultures, while at the same time enabling integration of universal technologies and techniques through discrete recourse. And this way of sort of bringing the local culture together with the, you could say, more standardized and universal principles, we find very intriguing and interesting to dig into. And also, when we speak about tectonics or tectonic theory, we find it also being embedded in a similar cultural amalgam of knowledge and practice or practices. So the thesis for the project was that materials can be said to have an intrinsic tectonic quality. Hence, the historical building culture and the craftsmanship of thatch are founded in the nature of the very stem of the reed. So it's sort of like the grass or the reed itself. Also, I've been reflecting upon recently that it is one of the few materials that you just cut it off in the field or in the swamps and you bring it straight into the construction. It's not treated in any way, it's just held, which is actually, I don't hardly know any other material in a similar way that is applied in a similar way, not being processed. So our research approach in this case, also because we were having the artist as an internal reviewer in the project, we were looking into historical building techniques similar to the previous projects, but also vernacular building traditions across the world where they have applied reed or straw, and also the works by artists. The interesting sculpture over there is actually by a Danish-British artist. I think he studied architecture before studying art. And he brought people from the Urals, the Bolivia, to build the boat and mixed it with the Danish thatching tradition as the roof. We wanted to study the bundled as a motif. The first form the material is getting after it's being harvested. It's being bundled in these sort of shapes, and we also wanted to look into, or just to mention that also other sorts of species can be applied in similar ways, but we wanted to to only focus on reed. We also wanted to look into the thatch elements again, the traditional craft and the tools, how they need prefabrication. So in this case, we had we set up the challenge not to apply hardly any other materials but biogenic materials. So the wooden frames you see are put together with wooden nails, and the straw or the reed is held by straw rope. So we also wanted to test different sorts of surfaces, because people have asked what happens in case you have burned the surface already, like the Japanese shiguban. How does it work if it has been charred already? Does it burn equally quickly and easily? And so that was also part of the setup. We had a baseline, which was untreated, clay-treated panel, and then finally the shiguban-treated panel. And this was also tested at the Danish Fire and Security Institute, and we had some preliminary conclusions that were that the charred surface gives no fire protection whatsoever. The clay delays the fire to reach into the reed, and the baseline burns as we more or less expected. This is being tested in a different way, as different from the setup we are testing right now, or have been testing over the summer. What we also found out was that when the panels had been treated with clay from the outside, in the previous projects we have inserted the clay into the structure of the reed, but in this case it was it was sprayed from the outside, and it made this sort of relief surface. So as you may see that small embers can the fire can keep on going behind the clay, which was a problem. But this was the first testing regime with the panels, and the second one was about the structural elements. How could we apply reed for structural purposes, and could we sort of bundle it and sew it together or tie it together in different ways to make it give it structural properties. So we were inventing this method of sewing and tying the bundles together, similar as when you do basket weaving or sewing, and put together these huge or large bundles of reed into arches and had them set up. So as for the dissemination, we didn't get to test structurally, how do you say, the load-bearing capacity of the arches, the reed arches, but we would very much like that, but we didn't have time for that in the project. But we were asked to disseminate the project together with the rest of the other material groups that had been part of the larger project for the Copenhagen Contemporary, which is an art museum, contemporary art museum in the center of Copenhagen. And we were, as you see, part of the exhibition here. And parallel to this, we were also exhibiting the processes of the project, how we got to the final, the final structural pieces we exhibited at Copenhagen Contemporary, and also the Museum of Design, or the Design Center in Malmö, Sweden. We're also interested in bringing in 4 projects from the Copenhagen, or from the architectural school exhibition, in which we were also part of. So it has been, I mean, broadly disseminated after that. So the summary of this project was that we found out that still reed is an unexplored building material. There's so much to do, still much to do. It's a regenerative perennial plant, as I mentioned. It holds carbon storage. It's used in structures throughout history in most regions of the world. We find that studies into reed's aesthetics also very important and interesting, where we can employ construction techniques as sewing, weaving, and tying strings for prefabricated facade panels and the arches. And also it has a direct relation or proportion to the body, the human bodily experience. It's like a prism that is connecting our senses to a spectrum of ecological contexts that conditions the use of viable building materials in future architecture. And it offers a direct coherence between humans, our growing nature, and the built environment. So from that perspective, we also find that it's somehow very much engaging material. So now I'm going to finish up, just mention or present some few slides from the project we're working on right now that also led to the Deserta Ecofoli collaboration. And this is the group of people we are now in the present MUDP2 project. Also now having more people like a large-scale entrepreneur part of the project, and the eco-cocoon manufacturer who has developed straw elements for, I mean, it's highly advanced straw elements for biogenic load-bearing construction. And the main statement or architectural problem here is, how do we create biogenic building culture, and how can craft tradition qualify industrialized construction? Somewhat similar questions we keep circling around, but it's about bringing the craftsmanship or informing industrialized manufacturing rather than, how do you say, reducing the craftsmanship. So it's more so vice versa, that we want to bring the craftsmanship into or reform industrialized construction by crafts approaches. And in this case, we have now over the summer tested a full-scale facade in 2.5 stories, in which we have tested the different joints and the different sorts of building principles as for protecting the joints between the different stories, and also between the panels, and as for the openings and the panels around the openings. So this has been, I mean, Johannes was showing this project on the other day at the station, the desert station, and we. I mean, that could be a full lecture, as we know, in itself. But it's still a project we haven't finished, and we are actually going home to do more tests in late February, March, and to find out if we thatch even tighter and with new techniques, if we can control the fire better. So it's not a matter of if it could not burn. It may burn. We know it burns, but it's about controlling the fire. And similar structural prefabricated facade elements we applied for the as part of the project for the Arquitectura Biogenica project, Deserta Ecofoli, where Thomas produced together with his team to produce the facade panels, and also Johannes and Thomas went to Venice to put them on the facade as a prefabricated system, having tested it already in Portugal before that. And at the moment, we are the exhibition at our school together with other researchers and teaching projects called Imagining the Future, in which we are looking into how to move into a new sort of, you could say, beyond the climate crisis, but into new ways of building and of looking into future, in our case, construction and architecture, but there are also many design projects and other sorts of projects. And for this, we also have now built similarly but different, the same facade, but also having reused the panels we applied for or built for the Triennale project you see to the very left. They were never meant to be stacked on top or built on top of one another. So we have applied reused roof tiles to cover the joints, having eelgrass behind the tiles. And the second panel, you may not see that, but that has these are very short straws that are applied for the built into a wet clay render or panel So I mean, they're only like 10, 12 centimeters long, but they're from the outside, it looks like a regular thatched panel, but it's a completely different technique. And then the last two panels are similar, somewhat similar to both the Deserta Ecofolie and the testing we're doing right now. So this is where we are now. We are in Deserta Ecofolie lab number 2, I believe, in the Alto Portage project. We together with Pedro and Pamela and the team at the Desert Lab to be part of the next generation, the next version of the Deserta Ecofolie with the facade. So this structure is now waiting for the new panels that we have been working on over the past couple of days in the desert, and we're looking very much forward to that. So more to come. This is it. Any questions? And maybe Thomas and Johannes, you can come up here. Hmm?
I would like to related with the industry, because of course you are working on prototyping solution and thinking from natural processes, and you are trying to change something in the beginning of any industrial process. So how do you imagine the process or the way from the point where you are now to the real industrialization of this kind of elements or construction? Because there are so many things that you have to do.
Yes.
You have to do. Because normally you work with the industry, but you are trying to create an industry, I mean. So my question is, how do you manage this process?
That's a very good question. Actually, both the MUDP projects, number 1 and number 2, part of the, how do you say, the demand of getting the grant is actually to answer to that question, which is, as I said, difficult because we probably already know, and I'm looking at you, Thomas, that we have also I have worked many years with masonry construction, and knowing that the brick blocks I was showing you had been part of German building construction or practice for like 25 years, 20 years ago. So now it has been part of German building construction for like 40, 50 years, and it has not yet been implemented into Denmark, which is just like that, right? So knowing that coming from the idea and innovation to the industry, bringing it into like a new market, in this case, the Danish market, is very, very difficult. Similar to this, I believe that most of our research is more so to document, in this case, I mean, what happens with the fire, because that's one of the main problems or showstoppers as for getting it accepted or getting the building regulations to be changed that we can apply it. At this moment, this way of building is illegal. We cannot get the how do you say, the building permit in case we want to build like this. It would be very, very difficult, maybe for experimental building, but this is just one of. So in case we should change the industry, it's a long haul. It takes a long time. And I believe that since we've been working on this for like 8, 9 years now, more and more people, also due to the fact we have to change into other sorts of materials than fossil fuel based materials, and concrete and steel and masonry, there's a greater interest in trying to use these materials, but it is very difficult. It's not easy. But I believe our approach, or our, how do you say, vision is to create the documentation for the industry to do it themselves, We are not part of the industry. We are academics, right? So, but we will sort of inform the industry.
We can also see that from the industry, there's a lot of interest from the industry, so also to collaborate with us. So also some of the collaborators in the last projects were manufacturers of prefabricated wall elements, for example. So that is a way that the industry also learns from us and we from them, so that there is very much interest. It's also due to the regulations in Denmark, because now there's rules for how much CO2 a building can have per square meter. So it's not only a hobby, but it's also for the industry a necessity to lower the CO2 footprint. Yeah. And then at the same time, we've also started looking at tools that the industry use. So we've also been trying to put this, for example, in Revit. So also to look at different levels of industrialization and also of how to plan and project this kind of buildings. So that's also how, also in collaboration with engineering that we work with a lot, that that it could be perceived as a type of curtain wall. So you could put it on top of any type of load-bearing structure. So now we have very much focus on wood structures and biogenic structures, but like here, I think you have to use more concrete because of earthquakes, especially if you go up in high floors. But in principle, the idea is that what Anna just showed is that you could put that on top of any structure. It could also be on top of a transformed building, like an old industrial building, you want to give a new function. So in that sense, we also try to separate the layers, because at one point we looked at integrating it more, but that made it so complicated that it was easier in a way to make separate layers. So that the facade is not load bearing, but what we do is really like a curtain wall hanging on a construction.
But
But regarding what you were talking about, I think it's key point of the regulations here that you said that most of these projects would be illegal to be constructed. And I think it's also a problem we have here with other innovations, and mostly with innovation that's a big problem. So I don't know if you have like I don't know, a path in the future, you know, how we're going to try to, I don't know, either change the regulations or try to make it a little bit more flexible, or try to make these comply with the regulations, or I don't know, what would be like to make these to work in the future, it has to basically be able to get it first. So I think that's the big question.
yeah, what we know from as for the fire regulations, we need, I think every time I ask, it's a greater number, it's a larger number. But to begin with, they said something about 12 or 15 tests to have it, how should I say, that it may have enough documentation. They may have enough documentation to change the building regulations, say that it works according to this. But so just one test, even though we did like, I don't know, many additional tests getting to the final one, it's not enough. But we think, we hope that maybe experimental projects can do other similar tests, and then they have now in the Danish Fire Institute and the it's called the Wood Information Office. They have now made what they call the Fire Bank. It's a bank of documentation that slowly collects the number you need to change the regulations. So this is both, you could say, a catalog for inspiration for clients and entrepreneurs and different companies who want to try these new construction designs. But this is only for experimental buildings so far. But in the long run, they hope to have it enough documentation to change the regulations. But it's very difficult. It's like, I don't know how to explain it, but it takes like years.
Well, the regulation there, but it's not that easy, just like to have something certified and say here it works. Like the government sometimes of materials they need to approve.
Yeah.
It goes through a year process, but so they have like I don't know, a path that you can certify your own projects, I don't know, do thermal analysis and structural and the fire one and the city one. So if you have like an amount of studies of that, you can apply it.
Yeah.
You go through.
Yeah, I know in Germany they have something similar to that. And I think in Denmark, I now forget the name of it, but they have like also tried to make up a new track, which is going to improve the building regulations so they can adapt quicker and more easily to these to the climate changes or to different or new sorts of materials and applications of materials. But it's a very slow process. It's very bureaucratic. We also, due to the fact that we're part of the EU, we also have to comply with the EU regulations. There's a lot of capital interest in not changing the building industry. We have a number of monopolizing companies, I would say, both in Europe and in Denmark, that like very much to keep on using mineral wool and what we have, right? It's concrete. Yeah. So it's I think we have to keep on pushing, and I also think from the perspective of changing the industry, it's also by educating architects who knows a lot about these ways of using these materials and being able to push the clients and push the agendas by being well informed and well educated. So that's part of our second strategy or third strategy, actually, to bring in the new generation of well-educated architects and empowered young people who are not scared. Yeah.
It's the standard. I heard you talking about one of the prototypes use seagrass and straw together. What about the humidity, for example, and abiotic attachment?
That's another good question, because we have over the past couple of projects we haven't been looking deep into how to say the building physics of humidity in the construction, but that's also part of it. Maybe Thomas, could say more about when you do thatching. It's a matter of not doing it too tight so it can still ventilate or dry out if it's wet, whatever. And at the same time, we want to thatch very densely and how do you say, close the joints with additional materials so it shouldn't burn. So we have it's like this reciprocal balance between what sort of parameters do we have to align with. We've only had part of the first structure. I showed the in situ structure was sitting outside for 5 months in the Danish weather over the winter. And of course, it was not a closed structure. We don't know if it was a proper house, people lived there, it would be different. But it didn't rot and it didn't get all wet. So we kind of think it will work fine, but we have to test that. That's going to be a new project. Not looking into fire, but looking into humidity. Yeah.
So, and thank you so much for the lecture. Thank you.
Sure.
See you tomorrow.
Yes.
Do you have any reference about it? If Indian groups in Lagos, Titicaca, between Peru and Bolivia, and they live in an island made by UFOs. And then one thing change in the material all the time. So you have questions about that? And you think about that, I think you have some things, right? Yeah, position. But you know that.
Yeah, understood.
Thank you.
I'm sorry, it's just the water. So hopefully it'll be like,
Yeah, it's constantly. No, it's up to you.
design it in such a way that it's easy to possibly different ways to remove the time.
Do you have any relation with